This lesson looks more at operations on radical expressions. We're going to look at adding, subtracting, and multiplying. So when adding and subtracting radical expressions, we want to think about like terms. And to make and look for like terms, we first need to simplify each of these radicals so that they are rid of any perfect squares, and then we can hopefully see some like terms that can be combined, and this is why we learned how to simplify them. So let's take a look and simplify. So this is 12, which is 3 times 4, and 4 is a perfect square. That's 3 times 2 times 2. So that pair of 2's, or that 4, simplify and come out as a 2. So the 2 comes out and a 3 stays in. So, and it multiplies here, so that's 4 root 3 minus 48 is 2 times 24, which is 3 times 8, which is 2 times 2 times 2. So you can see that there's one pair of 2's and then this other pair of 2's. So 2 2's come out, and the 5. And a 3 is left inside. So we've got 4 times 5, so that's 20 outside and root 3. Finally, 75 is 3 times 25, when we know 25 is a perfect square of 5 times 5. 5 is coming out and the 3 stays in, meaning we've got 4 times 5, which is 20 root 3. Now, this is what I mean by like terms, and this has been alluded to in previous videos, but so the main point is here that we have 4 root 3's minus 20 root 3's plus 20 root 3's. So basically what's happening is it's as if we said we have 4x's minus 20x's plus 20x's. So we can just add them up. 4 minus 20 plus 20, oh, that's equal to 4. So that's just 4 root 3's. Let's try with this other one. This one has cube roots on these two, but not on this one, so you have to be careful. Here we're looking for triplets in the factors. So 16 is 4 times 4, which is 2 times 2 times 2 times 2. That's one triplet of 2's that comes out, and 1 2 that's left. So that is going to be 9 times 2, which is 18, cube root, and what's left, that 2 is left inside, and 54 is 2 times 27, and 27 is actually a perfect cube of 3 times 3 times 3. So the 3 comes out and the 2's left inside, so that's plus 3 cube root 3 of 2. So don't forget the cube root, because now this other one, this is also 2 times 2 times 2, but only a 2 comes out because it's a square root now, so it's 2 root 2. So the cube root terms can be combined because they have the exact same endings of cube root 2, but the square root cannot be combined because it is not a like term. So you can say that you have 18 cube root 2's plus 3 cube root 2's, which is 21 cube root 2's minus 2 square root 2's. And that's all you can do if it doesn't simplify further. Let's take a look at another one. This 3a, that can't simplify at all. But this here, this is 3 times 3 times 3. So one pair of 3's comes out, 1's left in. This is a to the 2, a to the 2, and a to the 1. So 2 a's come out, and 1's left inside. So this simplifies to be root 3a plus, and now this here will be 2 times 3 times a squared as the front term, so the 6a squared root 3a. Now you can see that you could mistake that for a like term, but the like term includes all letter parts as well. So the only way this would be a like term is if this one had an a squared, but it doesn't. So since it doesn't, you cannot combine those like terms because they aren't like terms. So you just leave it then. Let's continue some more complicated looking examples. So we've looked at factoring, so we can actually factor polynomials as well. So this here would have been 4x plus 1 in factored form, and this here is x squared x plus 1 in factored form. So the 4 becomes 2 when rooted, but the x plus 1 term is left, and then x will now come out as an x, and the x squared comes out as an x, and that's root x plus 1. So again, it kind of looks like the same thing, but it's not because of this x. This would have to be 2x root x plus 1 in order for these to simplify further. So this is as far as we can go here. Let's take a look at the next one. So this is 2 times root 40 over 9. So the root can split. So let's try that. So 40 is 2 times 20, which is 2 times 10, which is 2 times 5. So that leaves us with 2. The 2 comes out, so this is that 2, and then the 2 comes out from the root. And this is over 1, so this is all in the numerator. And then in the root we still have 10. And I have split the root according to our rules. And the bottom is now a 3 minus 7 times, that's in the numerator. And this is a times here, it's kind of hidden. And this one's already split. The root 3 can't do anything, but the root 27, that's 3 times 3 times 3. So that's 3 root 3. So we can have some simplification going on here. The root 3's can cancel, so we have 4 root 10 over 3 minus 7 over 3. So you can either leave it like this, there's no like terms, or you can say 4 root 10 minus 7 all over 3 because of the common denominator. Alright, and let's check this one out. So we've got cube root of 5 over cube root of a to the 6. So what's that? Well, that's a squared, because a to the 2 to the 3 cube rooted leaves you with a2, plus 3a, that's on top, times cube root of 125. But what's cube root of 125? Oh, you should recognize that one, because 5 cubed is 125. So that's times 5 over cube root of a to the 9, which will be a to the 3. But here we can simplify these a's, so this a and this a cubed will leave us with a squared in the bottom and a 1 here. So we've got cube root of 5 over a squared plus 15 over a squared. And again, we have a common denominator, so we can say cube root of 5 plus 15 over all over a squared. And that's as simple as we can go there. With multiplying, it's just like what we've done before. It's just like what you would do with multiplying polynomials. So you've got your distributive properties, right? So that's one term times the other term. And this term again times this term. So I'm going to write this one out in a little more detail just so you see what's going on, and then the other ones I'll write in more of a simplified format. So 2 root 5 times 3 root 5. Notice this is all multiplication. So that's the first term, and then the second term is going to be a minus 2 root 5 times 5 root 2. So these are all multiplications in here, so we've got two terms, because this minus is separating them. We can rearrange this to look like 2 times 3 times root 5 times root 5, which is the same as root 5 times 5, and 2 times 5 or root 5 times 2. So that's essentially what's happening directly to there. And then we have 6 times root 5 squared will be 5, minus 10 times root 10. So that's equal to 30 minus 10 root 10. So let's try this next one. So we've got distribution all the way here. So this is not a special format of any kind, so we can't really take any shortcuts. So let's just go first times first. Will be root 3 times root 6 is root 18. Root 3 times negative root 3 will be negative or root 9. 2 times root 6 will be positive 2 root 6. 2 times negative root 3 will be negative 2 root 3. And so 18 is actually 2 times 9, and the 9 becomes a 3, so that's 3 root 2. And then that becomes a 3 plus 2 root 6 minus 2 root 3. And now we look for like terms, but we have no like terms, they're all different, so that's all we can do. Let's try the next one. Make sure you're trying these as well. So the first times the first will be root x squared, so that simplifies right away to x, so eventually you'll just see that right away. Now here we've got plus a root x times cube root 2. Can't really do anything with that because they're different kinds of roots. But the next one is minus cube root 2 times root x. Okay, we'll look at that in a sec. And then the last one is minus cube root 2 times cube root 2. So it's all under a cube root there. So I've written it out completely, but this should ring some bells. The fact that you have two brackets with the same first and the same last term, but with a minus and a plus. Do you remember that? Well, that was the difference of squares, and remember with the difference of squares, the middle terms always canceled out, and indeed they do here as well. So you could actually directly go and say, well, this will be root x squared minus cube root 2 squared. And that's essentially what we get. Root x squared is our x minus our cube root 2, which is times 2, which is cube root 4. So that's from the difference of squares formula. You should remind yourself of those special formats. They become quite useful. And again, you can see the same thing here. You have the first and the last being the same. So if you multiply this out, and you can go ahead and do that, but I can already see that the middle terms will cancel out. So because of these rules that really come out straight from doing it over and over again and not wanting to do the same thing over and over again, you can see that it'll be the first term squared minus the last term squared, which is the difference of squares formula. So this is our a squared minus our b squared, and when we square it we get 4 times 3 minus 25 times 2. So that's 12 minus 50, and that gives us negative 38. Hey, this one's actually a number. Alright, now this one is also a special format. So you could actually, you actually have to be really careful with this one. The biggest, most common thing to do with this is to say, oh, I'm just gonna square both of these things. It's a minus, right? Square it. So yeah, isn't it just like this? Careful. So you've got a bracket and it's all being squared. This actually means that you're taking the bracket times itself. So if you were to write it out and make yourself sure about it, you would write it out like this and go through each piece, expand it completely. But just like the difference of squares, where the middle term canceled out, remember this one, the middle term doubles up. So really we're going to be left with the square of the first term times itself and the square of the last term, but the middle term will be the minus because of these double, and it was whatever the middle term is, which was 3 root q times 2 root p. So you can convince yourself of this and multiply it all out, but you'll see this is what ends up happening. So that's 4p minus 2 times 3 times 2, 6 times 2, 12 root pq, and it's just alphabetical order that way, plus 9q. And some more multiplying. Keep in mind your special cases. These are really depending on you knowing your special cases. So you can kind of see the structure here. You've got your big A plus B, A minus B. So if you can view that structure a little bit, you can see that whatever this is will be your first term squared minus your last term squared. Your first term is your root 5 minus root 3, and your last term is your root 6. But root 5 minus root 3 all squared also needs to be expanded, and that's to be expanded by the same formula that this next example will be. You could write it out as bracket times bracket, but remember the middle term doubles up. So you'll have root 5 times root 5, which is 5, minus twice root 5 times root 3, plus root 3 squared, which is 3. And then this part, which becomes 6. So if you simplify that, you get 5 minus 2 root 15 plus 3 minus 6. 3 minus 6 is negative 3. So that's 5 minus 3, which is 2 minus 2 root 15 as the simplest form there. And finally, let's look at this Mondo example. Now, these are more difficult examples, so I don't think these are completely obvious at all. But I'm showing them to you just so you have some more examples to see of the more complicated ones. So here you also have the a minus b all squared, and remember this was what you would have seen and what you would have developed by multiplying out the two brackets. When you multiply and FOIL out the two brackets, you get a squared minus or plus, depending on what's there, twice the a times b term, which is the middle term, plus the b squared. So if we follow that, we get our root x plus 1 squared minus twice the root, which is x plus 1, x minus 1. That's the middle term. I just multiplied the root in there. And then plus the root of x minus 1 squared. So that's coming from this formula, but you could multiply it all out longhand. So this gives you x plus 1 minus 2 root. Now what's this when you multiply it all together? Well, that's actually a difference of squares, which is x squared minus 1 plus x minus 1. So we've got two x's, those are like terms. 1 minus 1 go away, minus 2 root x squared minus 1. We can't do anything with this because it's not the same term being multiplied by itself, but it just looks nicer together like that. That's a pretty hefty question there, so gives you an example of a more difficult one. So keep practicing.